Hey guys. All right. All right. So what number do you want to see from last night's homework?
Okay. I want to see
59.
Okay. 51.
Liv, you look different today. Liv, go ahead.
51.
51. Okay.
I mean, it's true. It doesn't look like me.
All right. So 51. Let me go to the page here because then I can do it. All right, let's jump down here. Oops, didn't want to do that yet. Guys, I need your... Shh. This has got to stop. Okay? My head will literally be splattered all up there. You don't want to see that. All right? 51. It's 5 minus 1 over x between 1 and 4. And you're asked to find the mean value theorem. And mean value theorem said what? You integrate between a and b of f of x, right? What's that? Times b minus a. Okay, well, let's go look at it real quick. All right? And you set it equal to the function times b minus a.
Oh, yeah.
Okay? So you set it equal to the function b minus a. Okay? And what you're looking for is the x value. You're looking for that c. Okay? So here we go. We set it up like this. 5 minus 1 over x between 1 and 4. And f of, you basically write 5 minus 1 over x. That's f. You're going to solve for that. Times b minus a, which is 3. All right, let's integrate this. This is going to be 5x. What's the integral of 1 over x? ln of x between 1 and 4. Okay. So you basically get 20 minus ln of 4 minus, plug in the bottom, 5 minus, what's ln of 1? 0. Okay. So you get 20 minus ln of 4 minus 5. So that's going to be 15 minus ln of 4. That's the integral part right here. Right here. You can keep ln's in your answer, okay? So now I've got this part now. I'm going to set that equal to that. So that's really going to be what? 15 minus 3 over x. All right, let's multiply everything by x. Let's get rid of our fractions here, okay? So that's what I'm really trying to... Actually, I can do this. Let's subtract 15 from both sides. They're gone. So now I don't even have to do that, okay? There's a trick here. You can flip both sides, right? So it's 1 over ln of 4 equals x over 3. We multiply both sides by 3. There's your x, minus 3 over ln of 4.
I got the answer. I just tried to flip and I just could not figure out how to flip it.
Yep.
Okay, cool.
All right. By the way, guys, here's a negative here. I forgot to bring that down. So in a negative, that actually makes it positive. Okay?
Okay. I have a question.
Yes.
So for 52, I got all the way down to 7 over 3 ln 2 equals 2x.
Okay.
How do you condense past 2 to the x?
Tell me again what you had.
7 over 3 ln 2 equals 2x. 2 to the x. Oh. Can you do all of 52?
Let's do all of 52. Let's just make sure we're supposed to be there. Okay.
Very long.
So we're going to integrate it between, this is number 52. I know. And we're going to go from 0 to 3 of 10 minus 2 to the x. And we're going to set that equal to 10 minus 2 to the x times b minus a times 3. All right. Okay. All right, so let's integrate this. We get 10x minus, and what's the integral of 2 to the x? It's ln of a.
No, it's a to the u.
A to the u over ln of a. Okay, so a to the u over ln of a. Okay?
Yeah, I got that. I know how far we move.
All right, so we get 30 minus 2 cubed over ln of 2. All right, so that is 30 minus 8 over ln of 2 minus, I got to plug in 0. All right, so I get 0 minus 2 to the 0 over ln of 2. What's anything to the 0 power? 1. So that really becomes 1 over ln of 2. Okay? So, and there's an, let's see. This is the top minus bottom, and now I'm sitting in here. Yeah, there's a negative. Thank you. All right, so this is 30 minus 8 over ln of 2 plus 1 over ln of 2. So if I have, think of it as I have 1 of them, take away 8 of them, that gives me negative 7 of them. All right, so that's just the integral part. Set it equal to 10 minus 2 to the x times 3. Okay? All right, well, I can kind of times everything by 3. So this is 30 minus 3. Do not do 6 to the x. Okay, it does not work. 3 times 2 to the x. That's like saying x times y to something. Okay, you really just can't combine it. All right? And so then I'm going to subtract 30 from both sides. They're gone. So now I'm down to negative 7 over ln of 2 equals negative 3 times 2 to the x. All right, you're not going to like this one, but I'm going to divide both sides by negative 3. Okay, so it becomes 7, 3 ln of 2 positive equals 2 to the x. What's that? Oops, sorry. Yeah, I divided by negative 3. Okay, and that cancels. Okay, just think of it like a coefficient. How do I get rid of 2 to the x? ln both sides. Okay, so it's a big mess. ln on the left is ln of 7 over 3 ln of 2 equals ln of 2 to the x. The rule says I can bring x out to the front. Remember the power? ln of a to the b is b ln of a. So this becomes x ln of 2, and then I just divide both sides by ln of 2. It's ugly, but that's what x is right there.
I like this ln stuff.
Okay? Yeah, ln's are fun. Okay?
And it's not even natural. Is it natural log?
What?
Isn't ln natural log?
ln, all right, real quick mini lesson on ln. Shh. You started doing things like this, like 2 cubed equals 8. So we had these things called logarithms, and you rewrite it. It's basically like this. This is called exponential form. This is going to be log form. So it's going to be log base 2 of 8 equals 3. It's 2 to the 3 equals 8. That's how you rewrite exponential into log. Okay? Then we started dealing with what's called common logs. All right? That was special logs, and when you don't see a base, there's an invisible 10 there. Okay? So if I say, what's log of 100?
10.
No, it's 2. Okay? What this is really meaning is log base 10 of 100. And 10 to what power is 100? 10 squared is 100.
Oh.
So when we have base 10, we call that a common log. Then we're like, this guy Euler or whatever, he came up with a neat idea that, and I'll just cut to the chase. They realized a lot of things in nature happen to be log base E. E is this constant, okay? 2.7, blah, 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 blah. All right? It appears nice. And so what they said, E is a naturally good base to use. Hence, log base E means ln of x.
Which is natural log.
Which we call natural log. And again, I don't know the history, or I could be blowing the story way out, but the E is kind of like a natural base to use. So that's why they call them natural logarithms, all right? So when you're saying ln, you're really meaning log base E. We could have done this whole problem with log base 10, okay, if we wanted to, a common log, okay? But you'll get the same answer. So I just love ln's. It makes it easy. We've got properties for all that, okay? So that's ln in a nutshell, all right? So again, follow the formula. We'll keep integrating. Don't think by any means we are done integrating. Okay, we are just getting started. All right, we're going to learn a new method tomorrow. And again, we're going to be integrating a boatload of problems. Okay, Sophie.
Can we do either, let's see one.
What?
At 56.
56?
Any of them.
All of them.
Fine, yeah.
Okay. Yes, sir.
The integration for tomorrow is gonna be on Tuesday test or no?
No, when we learn that new method of integration, we're stopping. Tuesday's test is strictly 4.4, which is mean value, average value, first fundamental theorem of calculus, which is a definite integral. And then we're going to learn the second fundamental theorem of calculus today, and we're going to try to get to it. All right? All of 4.4 will be on. And Friday, we'll lay it out in a nutshell as well. And we'll record and do problems and stuff.
So Monday, we didn't take any.
Monday's no school.
No.
Yeah.
This Monday.
This past Monday.
Gone.
Yeah.
You didn't take any new notes.
No, we took a quiz.
Yeah, which I did.
And then we started on 4.4.
Okay.
Yeah. Okay. So yeah, it's kind of really from this week of material. All right. Someone wanted to see 56. Okay. So 56, we're finding average value. And remember, this is nothing more than sticking a 1 over b minus a out front of the integral, a to b of f of x. That's all average value is. Okay, now we're going to do this problem, and then I'm going to have to kind of stop there, but I don't want to leave you in the dust. I am going to talk about and try to put a nice bow on the difference between mean value theorem and average value. Kyle was just kind of hung up on they look identical, how are they related, and all that kind of stuff. So I said, all right, I'll draw pretty pictures today, and we're going to try and do it. But instead of just drawing pretty pictures, we're going to give numbers to these pictures. I think if you see an example, you'll understand the difference between the two. Okay? All right, let's do this one here. We've got 4 times x squared plus 1 over x squared. We're doing it from 1 to 3, and then it's 1 over 3 minus 1, which is, we have a 1/2 out front. All right, right off the bat, I can bring my 4 out front. So now I got 4 over 2, which is just 2 times integral 1 to 3 of x squared plus 1 over x squared. Pause a little bit. They have a common denominator. So x squared over x squared, that really becomes 1. And then 1 over x squared, we like to rewrite like that. So that's what we're down to now. Now it's kind of easy. It's just, it looked intimidating at the beginning. The integral of 1, x, and the integral of x to the negative 2.
X to the negative 3 over negative 3.
Careful. You're adding 1 to negative 2.
Negative.
X to the negative 1 over negative 1. All right, let's clean that up. Hold on one second. We're going to bring this negative up here, so it's basically going to be like that. 1, 2, 3. Now remember, I'm going to have a 2 out front. Z?
With the other x squared go?
X squared over x squared is just 1. Anything divided by itself is 1. And then 1 over x squared we rewrite as x to the negative 2. Okay? All right, let's plug in top minus bottom. 3 minus 1/3 minus, let's plug in the bottom, 1 minus 1. Right? 1 over 1 is 1. Okay, 3 minus 1/3 is what?
2/3 or
8/3. And then minus, what's 1 minus 1? Okay. And so therefore, it's 2 times, it's going to be 16/3 is the answer. Okay. Nope.
I don't have a question.
Yeah.
I do have a question. Do we have a rule for e to the x?
Yes, integral of e to the x is e to the x.
The inner.
Yeah.
Because the derivative of e to the x is e to the x, therefore the integral of e to the x is e to the x. They go back and forth, okay? What you don't know how to do, guys, believe it or not, is something simple like that, e to the negative x. We don't know how to do that yet. Believe it or not. And we're going to learn that tomorrow. It's our first method of integration.
Oh, I thought you meant like all of math department.
Oh, no. No, we, as of today, 11:30 on February or January, whatever date it is, we do not know how to do it, okay? All right. Now, in question 55 through 60, it says find the average value, all right, and find the value of x where it equals its average value. So what you have to do is take the original function and set it equal to that. Where does that average value happen, guys? Oops.
I thought you done after that.
No, we got 16/3, which is the average value, but the direction says, where does that average value happen at? Okay? So all you do is set that equal to your original function. All right, here we go. I'm going to multiply, or I'm going to divide both sides by 4. All right, so that becomes 4/3 equals x squared plus 1 over x squared. Let's clean this up. That's 4/3 is equal to 1 plus 1 over x squared. So I'm going to subtract 1 from both sides. So 4/3 minus 1 is what? 1/3. Whenever you have a fraction equal fraction, you can flip both sides. So 3 equals x squared. So x equals square root of 3. That's where it occurs at. Okay? Does that make sense?
Yeah, you have to put positive, negative.
No.
No.
If it's negative, it'll be you'll have a negative. Hang on for the ride. But we take the positive. Yes, Z.
How do you get to the 1 plus 1 over x squared?
I clean this up. X squared over x squared is 1. 1 over x squared is 1 over x squared.
Oh, so you separate.
I separated them. Yep. Okay? Because if you didn't, you'd have too many x's hanging out. So they luckily kind of get rid of each other. All right, so this is where this happens. All right, now I'm going to stop there, but what I'd like to do is put a pretty bow on all that and kind of explain graphically what you were doing here between average value. When you were back in elementary school and you learned something called mean, median, and mode, what did mean mean? Average. So think of mean value theorem as average value theorem. And then what did we also find? Average value. So mean value theorem and average value are kind of in cahoots with each other. This is what it's really meaning, okay? Let's do this graphically with a real example. I'm going to have a function here, x squared, between 1 and 2. Now I got to draw this like 4 times here to kind of drive this point home. What you're really doing is this. You're drawing, like, this is a circumscribed rectangle. What's the area of this rectangle here?
Well, we don't know the height.
Yeah, you do. At 2, what is the height? The function's x squared. 4. So this is a 4 by 1, so that has an area of 4.
Oh, okay.
This guy is a small rectangle. What's the area of that?
1.
1 by 1, or 1. What would you do to find the average of that?
You would add and divide by 2.
Bam.
Wouldn't the first one be 2?
I'm so educated.
No. What's the width here, Amelia?
1.
And what's the height?
2.
What's 2 squared? No, this 2 is the x value. I want to know the height.
The height is 2.
No, that's
No, don't tell him. He's got to get this for himself. He's got a brain fart right now. At x equals 2, what is y? This is my y-axis. That's okay. No. We always have brain farts.
Yeah, cause
He got it.
So 1 and 1
Yeah.
and 2, 4.
2 squared, that's a height of 4.
4 and 4 times 1. Oh.
Yeah, he knew that. He just had to get past some inner demons here, so he's good. All right. So we found the average of these areas. It's 5 halves. Let's find the actual real answer here. What would we do? We would integrate x squared between 1 and 2. Okay? So that would be what? X cubed. 3 over 3, 1 to 2. That would be 8/3 minus 1/3, or 7/3. What's 7 divided by 3?
like 2.33.
2.333. 5 halves is 2.5. They're pretty darn close. One's an average, one's the exact. Okay? Now, what we're trying to say here is that they are kind of related. What mean value theorem says is, guys, in between here, there is a C value at some X point, such that this is happening. My fourth picture here. 1 to 2. There's some value here. This is what mean value. All you did is find the average value. Okay? I mean, what was the average value of this guy right here? You take your answer 7/3, and you would times it by 2 minus 1, or 1 over b minus a, right? What's 1 over b minus a? 1. Okay, so we got 7/3 as our thing. That is our average value. Where does it occur at? So here's what I'm looking for, this value. And if you look at it, I'm kind of looking at the area. Notice I've got a little too much and I'm missing some. Okay? So that's what's happening, is at that point, you've got an average value. And so that's what you're doing. You're taking your average value and setting it equal to your function. My function was x squared. Okay?
That's the average of that.
Hold on. 7/3 is my average. That's average value.
But it's not the exact area?
It's the exact area, but in my case right now, remember, it's the integral times 1 over b minus a.
Okay.
My case happens to be 2 minus 1 is 1, so 1 over 1 is 1. Okay? Now, we would set that equal to my function, so x equals the square root of 7/3. That's where my average value happens. Okay? So that's this square root of 7/3. What's that one?
1.527.
That's where 5 what?
1.527.
Okay.
1.53.
Perfect. At 1.53, guys, that's where my average value happens. Okay? It's right here. That's the kind of the relation between mean value theorem and average value. If you look at the two formulas together, if you look at here's one here's average value, or mean value theorem. It's a to b of f of x is equal to f of c times b minus a. Right? That's our mean value theorem. Multiply both sides by 1 over b minus a. So this is average value equals my function. So mean value theorem says that you take the average value and set it equal to the original function, and you're trying to find the c. C is the x value, okay? So it's at what point does the average value happen? Does that help? Kind of put a bow on it? All right. So what we need to do is we're going to talk about